Hey math students, in this video we're going to be going over a long time ago learned skill of long division of numbers. We did that in like elementary school, but the process of dividing numbers using long division is the exact same process that you will use in dividing of polynomials. So if we review ourselves how we divided numbers using long division, we can then apply those same rules and skills to polynomials. It's the exact same process. So let's look at our first example. Here we have 65 being divided by 5. Set that up. As you remember, we have our divisor and our dividend, and then we're asking ourselves, number by number, how many times does 5 go into 6? Answer is 1. We multiply those down. We subtract the remainders there, and then bring down the second digit to now be 15, and then we start all over again. How many times does 5 go into 15? Answer is 3. Multiply, bring that down, subtract, and here we have no remainder. The remainder is 0 is because 5 goes into 65 evenly. There is no extra remainder. But what happens if there is a remainder? So for example, 546 is being divided by 31. 31 doesn't go into that number evenly, so we have a remainder of 19. That is where fractions come from. So here I am saying that remainder of 19, it's still trying to be divided by my number of 31. So since it's being trying to be divided, I'm going to write that as a division problem, which we all know to be division, or represented as a fraction. So here we're going to separate out what was really being said in our fraction of 17 and 19/31. Here we have 17, and that is being added with 19/31. I just wanted to remind you what's happening between the number and the fraction. The operation there is addition. Now that is becoming really important as we go into the process with polynomials. Again, it's the exact same thing. So I want you to pause for a second. Can you see that repeated process as we just saw it with numbers? Can you see it here with the polynomials? So here I'm thinking, okay, okay, I'm going to think about x. How many times does that go into x cubed? X going into x cubed gives me an x squared. We multiply this x squared, we multiply it down. That's how we get the x cubed minus 1x squared. Subtract. Subtract, bring down the next term. Okay, repeat the process. How many times does that x go into a 5x squared? Answer, 5x times. Multiply over. We get 5x squared minus 5x. Subtract down. Get our 2x, bring our remainder down. So I hope that I'm illustrating here. The process here is exactly the same that we've seen with numbers. So going back to those numbers, if you remember our example of 546 being divided by 31, it gave us the answer, which is called the quotient, of 17 and 19/31. So in math, and always means addition. So again, the operation between that whole number and the fraction is addition. I want to think about an equivalency statement. So how do I prove myself that I've done this correctly? So if I multiply both sides, in this case by 31, I know it was going to be 31 because that's what I'm dividing by. So I know that if I simply multiply by that 31, this division of 31, multiplying with 31, it's going to cancel out. Division, multiplication, inverses. So if I multiply this left-hand side by that divisor, 31, I also have to multiply it on the second side. Now remember, we always have to distribute whenever we have addition or subtraction, so I can see my distributive property here. So this 17 is being multiplied by 31, but the 19/31 is also being multiplied. But remember what a fraction means? That fraction really means division. So if I have 19 that is being divided by 31, and now I'm multiplying by 31, these guys are going to cancel. That just leaves me with a 19. So if I were to simplify this right-hand side, guess what I'd get? 546, equivalency statement. I know that 546 is equal to 546. They're the same number. So that is a great way to check whether or not our division has been correctly. We're going to flip it and reverse it. We divided, so now we're going to multiply to make sure that we have the correct response. So I wanted to remind you all how we divide using long divisions with numbers, so that in this unit, when we are looking at long divisions of polynomials, we have that refresher of that process and the steps that are necessary to be, because they're going to be applied in the exact same way with polynomials.